Today we're going to be looking at reference angles. A quick review of what a reference angle is. It's the angle that's made with the terminal side of an angle drawn in standard position and the corresponding x-axis. And since we know about radians, we are looking at not only angles from 0 to 90, but also 0 to, I should say pi over 2. All those angles are small. Okay, so a quick review, if we look at number 1, or quadrant 1 here, the reference angle is actually the angle that is right in here. This is your reference angle. In quadrant 2, once we start and our terminal side is now in quadrant 2, our reference angle is from that terminal side to the x-axis. So our reference angle has now moved. In quadrant 3, it is still terminal side to the x-axis, so it is part of that angle right in here. And then in quadrant 4, to the terminal side, or sorry, from your terminal side to the x-axis, that reference angle is now located like so. So knowing those angle measures, they are actually all going to be less than 90 degrees or less than pi over 2 radians. There are 2 rules that you should be familiar with when you're finding reference angles. Based on where the location is at the terminal side, these rules do apply for both degrees, and then we will look at radians. Basically, it's a little shortcut for you, but the rule only applies when your angle is less than 360 degrees or 2 pi radians. Okay, so in quadrant 1, if we have, and we look at the picture up here, if we have a reference angle in quadrant 1, it is actually equivalent to whatever that angle measure is equal to. So our reference angle will be what the angle measures. In quadrant 2, this is quadrant 3, and quadrant 4. In quadrant 2, if we rotate into quadrant 2, look at your terminal side. To the x-axis is 180 degrees. So to find and go backwards, we need the difference between 180 degrees minus what that angle measure actually is. When we rotate and that terminal side continues on to go into quadrant 3, and now we have to take away that 180 degrees. So if we take our large angle, subtract out the 180 degrees that are above it, we'll end up with our reference angle. And last but not least, in quadrant 4, if we take that 360 degrees and subtract our angle, you will get your reference angle. And that should all be a review from what you did last year in Algebra 2. This is 0 and 360 degrees, and out here is 180. For reference angles, always, always, always to the x-axis. Okay, in radians, our reference angles will be different because we are no longer in degrees. Our angle measures are 0, pi, and 2 pi on the x-axis, and that's what we are interested in. In quadrant 1, 2, 3, and 4. So in quadrant 1, our angle will be, again, whatever the angle is equal to. So our terminal side and our x-axis are close. When we rotate into quadrant 2, we're now not subtracting from 180, we are taking pi minus that angle. And then in quadrant 3, we're going to take pi away from our angle to get our reference angle. And finally, in quadrant 4, we are going to take the difference of an entire rotation of 2 pi, take away the angle measure. So let's look at an example of each of these. So one example, if we look at an angle that is, let's say, 156 degrees. First, let's draw it. And what does that look like? Where is the terminal side? It should all be screaming, it's in quadrant 2. And it looks something like this. That's your 156 degrees. Our terminal side's in quadrant 2. So what are we going to do? Our rule says to take 180 degrees and subtract out our angle. So 180 degrees minus the 156 gives us a reference angle of 24 degrees. A second example, in terms of radians, let's look at an angle, a negative angle, 3 pi over 4. And let's graph this one. Remember, negative angles are clockwise rotations. So when we graph this, 3 pi over 4 negative is going to rotate clockwise and end up putting a terminal side in quadrant 3. Now our rule for quadrant 3 is to take the angle and subtract pi. But that's not going to work here since we have a negative angle. So because it's negative, we do have to first convert this to, well, what would the coterminal be in quadrant 3? So we take negative 3 pi over 4, and we are going to add 8 pi over 4, right? This is equivalent to 2 pi. And we end up with 5 pi over 4. So this angle here is 5 pi over 4. So our reference angle, now we can take our angle 5 pi over 4 and subtract pi. Well, what is pi in fourths? 4 pi over 4, which gives us a reference angle of pi over 4. Let's look at one more example. Without a graph, you could certainly do these. Sometimes you'll be asked to graph it, sometimes you won't. Let's look at an angle of 7 pi over 6. Well, let's think about that. Where is 7 pi over 6? The terminal side. Terminal side is in quadrant 3. Quadrant 3 tells us to take our angle minus pi. So our angle is 7 pi over 6. We're going to subtract out a pi, which is 6 pi over 6, which is going to give us a reference angle of pi over 6. So if you would prefer to draw a picture, absolutely 100% draw a picture every time. Or by looking at 7 pi over 6, we do know that it is 1 and 1/6 pi. So to draw it, would end up in quadrant 3. Your assignment is to complete the reference angle worksheet for tomorrow.